Hello everybody, uh, let me explain what you see here. I have managed to fire up my inverter, at least one side of it, one side of the MOSFETs and one side of this center tap transformer. This and this are two of the terminals of the two coils. I have one coil here and one coil there, and these are the 24 volts terminal, and there you have the center tap between the coils. And as I told you, one side of the inverter is hooked up, and on this side I have a recovery capacitor hooked up to two recovery diodes. They are ultra fast diodes, 16 nanoseconds recovery time, 600 volts and 15 amps each. And I have the probes of my multimeter hooked up with alligator clips, so they will be fixed there and give me a good voltage reading. Also, the lower probe is there, hooked up with an alligator clip as well. Okay. There's the recovery capacitor. It's a 200 volts and 1000 microfarads capacitor, and right now I have not turned on my lab power supply for the inverter because the fans will start and they will make a lot of background noise. So right now the voltage in the capacitor is 0.460 volts. That's close to nothing, and I have shorted it out, but it seems to be recharging because the diodes are ultra fast and connected to the to the coil of the transformer, and it possibly picks up background radiation. So I have my scope standing by. What you see there are channel 1 in the upper part of the screen, and channel 2 in the lower part and of the screen, and in the middle there you can see the sum of the two channels, channel 1 and channel 2, and I have pressed on the invert button, so that's actually channel 1 and channel 2 inverted, because that's how I was told that you can measure alternating current without using the scope's ground lead. So you can connect only the main clips or hooks or whatever. And wait, let me connect this back. And I have set the oscilloscope in that manner so that I can see what's going on in the transformer's coil. And now I just want to show you how does the inverter and the coil and the whole setup behave when it is activated, and how much energy and what is the voltage of that energy which is recovered in the capacitor. Well, how much energy can I recover? This being said, I will turn on the power supply. What you hear now are the fans. turned on, and this is, wait, let me short again the capacitor's terminals, and right now it is at 0 volts, and when I will activate the inverter through this switch, this is the switch for the main board of the inverter, you will see the voltage present in the recovery capacitor. So 154 volts, and this is for only a short period. And watch what happens when I short circuit the leads. You will hear a bang, which in reality is much more louder and noisier than you hear on the camera. It actually temporarily welds the tip of my screwdriver on the capacitor's terminals. So now the voltage is 0.7, and I will fire up my inverter once again, so you can see on the scope what's going on. The scope leads are connected to one coil of the transformer. I don't know if these are good or not, these spikes that you see. I don't know if they are good or not for my MOSFETs. If you have any ideas, feel free to comment or leave me a message. And this is where I got so far. Right now I have two ideas in mind. Either I place two capacitors which will be charged in alternating fashion. When one will connect, the other one will disconnect and connect to the load, so the load never sees the charging part of the circuit. And my other option will be to connect a step-down transformer to this capacitor after the diodes, and extract energy and rectify it with a bridge rectifier and place it back into the run battery. Like I said, if you have any ideas, feel free to comment, mail me, or whatever. Thank you.